Welcome back, guys. Week 9, day 2. Today is the first day of March. And this is a topic that we saw yesterday. We saw definitions of parallel lines, perpendicular lines, and we determined or we learned how to determine if two linear equations are parallel or they are perpendicular. We also determined the symbols that we're going to use for parallel and perpendicular. So taking into account this formula M1 equals M2 and the formula M1 times M2 equals to -1, we are going to write an equation now. So let's continue and place the date at the top of the page, okay? And today we're going to find equations that are both parallel or perpendicular to a given one and a given point. So instructions: write an equation for the line that is parallel and another perpendicular to the given line and that passes through the given point. And I have two exercises, okay? Y equals 6x minus 2 and the given point is 0, 0. And 4x minus 2y equals to 9 and the point is 8, -2. And we're gonna get two lines, two more equations. We're gonna write an equation for a line that is parallel and an equation for a line that is perpendicular. Okay, so for the parallel one, I've got the formula that M1 has to be equal to M2 in order for them to be parallel, okay? I have this in, what type of form is this written? Is it written in standard form? Is it written in point slope? Is it written in slope intercept?
In slope intercept form.
Very good. It is written in slope intercept form. So I can find out M1 because this is going to be equation 1. Okay, let's try to write it pretty. Okay, M1. What is the slope for this equation?
6.
6. Very good. Now I'm going to write the equation for M2. Now I need that M1 is equal to M2. Therefore, if M1 is 6, M2 is going to be
-2.
What would be the slope of M2? -2 is the intercept. In this case, B1 is going to be -2. But I'm talking for the slope 2. What would be the slope of a second equation if the slope 1 is equal to slope 2? And slope 1 is 6. How much should slope 2 be? 6, exactly. 6. And now you see this is 0, 0. Remember that an intercept is written as 0, -2 because it's talking about the y-intercept. So with that said, with this exercise in particular, what would be the intercept for that given point? Okay, let's do it another way. Let's forget about the intercept, okay? Let's forget about this because we're not graphing. And we found already that the intercept for this one was -2 because it's given in here, okay? This, -2, it's given in there. We don't need that, okay? We don't need it. What we need is to write it now an equation. We have a given point and we have a given slope. What type of equation can we write? In what form? Even
In point slope.
Exactly, in point slope. So let's write the formula for point slope. So y minus y1 equals to m, okay, give me a second, equals to m times x minus x1. And what is x1, y1? This given point. This is x1. And this is y1. So now I can go ahead and substitute. So I'm going to say y minus 0 is equal to 6 times x minus 0. I don't need that 0, so I can say y is equal to, I don't need the 0 either, so I can just go ahead and multiply 6x. This is the equation for a parallel line to this one that passes through the point 0, 0. Okay? And that's exactly what I was trying to tell you. The intercept 2, in this case, like I told you, this was supposed to be 0, negative 2. And if I have as a second point, and in this case in particular, it would be 0, 0. So my intercept was 0. So 6x minus 0. Okay, that's what I was trying to tell you. But let's forget about that. And let's leave it this way, okay? With point slope form for the given point. And that's all that you need to do to find a line that is parallel. We're going to do another one, so don't worry. Now let's find the one that is perpendicular. Oh my God. I don't know what's going on with this mouse. Give me a second. There, a perpendicular line. What do I need to do when it is perpendicular? When I have a perpendicular line, I need to have that M1 times M2 have to be equal to negative 1. I already have M1. M1 is 6, okay? M1 is 6. I need to find M2. So I'm going to say 6. I'm going to do it in blue. So I'm going to say M1 is 6. So 6 times M2 is equal to negative 1. I need to leave the M2 completely alone. Therefore, this 6 passes to the other side. Divided, right? So what do I have left? I got that M2 is equal to negative 1 over 6. I've got a given slope now, and I have a given point. And I have an equation as well that I can use to write it. I'm still using point slope form. I'm just going to substitute with the given information. So y minus 0 is equal to negative 1 over 6 x minus 0. I don't need those zeros, so I can say that y is equal to negative 1 over 6 x. And this is the line that is perpendicular to this exercise. Okay? Questions? Questions? No? Okay, let's do the second one to see if you understood. We got 4x minus 2y equals to 9, and the given point is 8, comma, negative 2. So since I have a given point, this will be x1, and this is going to be y1 for the parallel one. What is M1? M1.
We don't have a slope.
We cannot find it just like that, right? We need to do what? We need to rewrite this equation. I'm going to rewrite it over here in green. 4x, because this is in standard form, minus 2y is equal to 9. That is my equation. So let's find the slope. Let's write it in slope-intercept form. This 4x, let's make it easier and make the y positive because the y is negative. So let's pass this one to this side. If it's negative, it goes positive. And I have 4x is equal to 9 plus 2y. Now I have my variable y positive, but it's not alone. So the 9 passes to the other side, subtracting. So I have 4x minus 9 is equal to 2y. I need to leave the variable y alone. So the 2 passes to the other side, dividing every single term. Okay, so I have 4 divided by 2, x minus 9 divided by 2 is equal to y. 4 divided by 2, 2x minus 9/2, and that is equal to y. Now this is the slope-intercept form because I got the y completely alone in one side. Now, what is the slope then? What is the slope of this equation? What's the slope of this equation?
-9/2.
Are you sure?
Positive 2.
So 2.
Positive 2, because the slope is always the number next to the variable x. So positive 2. So if M1 has to be equal to M2 and M1 is 2, how much is M2?
2.
2.
2. Very good. Now we can rewrite and find our equation in point slope form. And since I know already my formula, I just need to substitute. I already identify x1, y1, so I can say y, this is negative, so I'm placing it positive 2, equals to 2, parenthesis x, and x1 is positive, so we place minus 8. And I'm gonna leave it like that because I'm not requested to write it in a different form. I'm not requested to write it in standard form. I'm not requested to write it in slope-intercept form. It just says find an equation, and that's the equation. It's not a simplified equation, but there it is, the equation, okay? Any question? Now, let's find the perpendicular then. For the perpendicular, I need M1 times M2 to be equal. Give me a second. Okay, I don't know what happened in there, but it doesn't matter. I need M1 to be equal to the multiplication of them both equal to -1. I have already here M1, and M1 is 2. Okay, so I just need to substitute, and I'm going to say 2 times M2 have to be equal to -1. I need to leave M2 alone, so this passes to the other side dividing. So now M2 is equal to -1 over 2. And I have my given slope and my given point. So I'm ready to find my equation with point slope form, okay? So now I have y -2, so plus 2 is equal to -1/2, the slope that I just found, parenthesis x, and x1 is positive, so -8. And that is my equation that is perpendicular to this line. Do you guys have any question about this? No questions? We good? Are you sure? Okay, then. So basically, this is what we are going to be doing in our classwork for tomorrow. Probably, not for tomorrow, not for Thursday. Probably, I will be asking you to graph the system. Maybe it is a system that I want you to graph. Maybe I want you to graph both lines. If I ask you to graph both lines, you're going to graph this one and the one that you find. You're going to see that they're actually parallel. And then in another coordinate plane, you're going to graph the original and the perpendicular one that you found, okay? And you can graph it using any method that you want. It could be intercept, it could be slope-intercept form, it could be point slope, okay? I don't want you to use input-output table because it will take you so long. And basically, this is the last topic for this workshop. Questions?